much to it, so you should be okay with this. So let's have a look here. So factorizing was a little bit hard to do because you kind of had to guess the numbers a little bit, whereas completing the square you don't have to guess, it's much more straightforward. Okay, so once the writing pad opens up, we'll have a look at that now. Here we go. So what I want you to do for me, just to start, I want you to expand. You remember what this word means, expand? Mm-hmm. Yeah. Expand this. And my hint is x plus 1 squared is the same as x plus 1 multiply x plus 1. Okay? So I just want you to expand this to get started. Yeah. Come on guys, focus now. I don't like separating students. Okay, have you done this one? Yep. So, we have x plus 1 times x plus 1 plus 2. So that would be x squared plus x, plus x plus 1 plus 2. So that would be x squared plus 2x plus 3. So, when we go from here to here, the verb is expand. And today we're going to learn how to go backwards. And that's called completing the square. Complete the square. So we're going to learn how to start from here and get back to here. This is called completing the square. So if you just write that down, and we'll have a look at a couple of examples. I'll show you the technique now. So let me just open up an example here. Completing the square. So does anybody remember the name for when the quadratic has a 1 in the front? Monic, yeah. Sorry, do you have this? Can I scroll down? 1 sec, okay. So we'll start off by looking at a monic quadratic with just a 1 at the start to get the basic idea. Okay. I think everyone has this, so I'll have to continue. Yeah. Okay, you all have this? I can grab it from the video. Okay, so Nader, this is more important anyway. This is the first example then. So we'll start off with something like y equals x squared plus 6x plus 18. So this is the example for when it's monic. Remember, monic means it's a 1 here. Okay. It's not very difficult. It's actually very straightforward, but you just have to be careful. Okay, so listen carefully. We know the answer will be like this: bracket, bracket, squared in x, and there's going to be a number here and a number here.
Yep.
So the first number is easy to get. It's very easy to get. All you do is you take this number and you half it. So half of 6 is, or half of plus 6 is plus 3. And that's fine. Okay. Then the next thing you do to get this number here is you take this, which is 18, and then you minus, and it's always minus, 18 minus this number squared. So that's a 9. So 18 minus 9?
9.
Positive 9.
Yep.
And then that's it. That's it. So I'll do a couple more examples, but that's the process, just that. So, yeah, the question would have been just complete the square of whatever. Yeah, so it would have been like this, later, complete the square of, let's do this one next, y equals, well, I won't worry about the y, x squared plus 10x plus 26. Okay, so, what goes here? 5, yeah.
Squares.
Now, it's 26 minus 25, so that's 1. And that's it.
Mm-hmm.
Starry, you look confused. Are you okay? Are you sure? Should I believe you? I'll believe you? I'll believe you, okay. Everybody try this one now, if you write it down. So I want you to complete the square, let's say, let's try that one. Try this one first. You know what, actually, yeah, no, try this one first. Okay, so the answer is this x plus 1 squared. And then it's minus 1 minus 1.
Plus 1.
That's minus 2.
Minus 2 then, yeah. Okay, try this one more of these. X squared plus 4x, no, sorry, x squared minus 4x minus 1. Yeah? Got this? So, again, pretty easy. What will be first?
Minus 2.
Minus 2.
Squared.
And then it'll be minus 1, minus 4. So you should have minus 5 here. Okay. So that's basic ones. So let me give you... let me give you another one to try. And then I'll have a look at non-monic next.
Mm-hmm.
So just one more to try here, but we'll put a fraction in it. We'll just say x squared plus 9x plus 105 over 4. You may need your calculator to try this. It brings some security and a feeling of safety to have it, yeah?
Feel more sweet.
Yeah, that's it, yeah. Okay, we have this one?
Yeah.
Yeah. So this would be x plus 9 over 2 squared. And then it's 105 over 4 minus 81 over 4. So that's just a 6 at the back.
Mm-hmm.
Yeah, let me write here, look, that 6 was 105 over 4 minus 81 over 4.
Mm-hmm.
So we squared 9 over 2.
Yeah. Yeah. Questions, Starry? Are you using English?
Oh, did you get the 6?
There it is there.
Yes.
Yeah?
And it's 6. Oh, yeah. My bad.
Yeah.
My bad.
24 over 4. Okay. Can we look at an example now which is not monic? Not monic.
Yeah.
Okay. I can scroll down?
Yes.
Yep. Right. 7x squared minus 70x plus 183. So important, this is not non-monic now. Okay, so let's see how to do that. Any ideas?
You have to put 7. You have to
Yeah.
put 7 in front.
You should take the 7 out.
Yeah.
So you'll get 7, big brackets, x squared minus 10x plus 183 over 7. So what's this called, the verb? Not quite factorize, the different verb. Not simplify either. Not common factor. Not factor. We're getting close, but we're not there. I'm sure I've said it many times. Not quite factorize. Not quite factorize. No, we're closer with factor. Factor out.
Oh.
Factor out the 7. Or take out the 7. Yeah. Although that makes it sound like you're assassinating it or something. So factor out the 7. Okay, so now we just do the process like normal. So this would be bracket x minus 5 and then 183 over 7 minus 25. That's plus 8 over 7. And then the last thing to do, what do you think the last thing might be?
7. Each.
Put the 7 back in, so that's 7 x minus 5 squared
plus 8.
So it's not really very different. It just has this extra factoring and multiplying at the start and at the end. So I'll give you one like this to try now. Okay. Can I scroll down? Yeah. Just a moment. Okay, yeah?
Yeah.
Okay. Try this one for me. Complete the square for minus 9x squared minus 90x minus 219 then. Finished it? Let's see what you got. Finished on the back there, yeah? No, I just wasn't expecting this to be so big. Just double check it. I think it could be. Alright, we'll have a look at this one now. Finished it?
No.
Yep. Nearly. Yeah, this looks like it. Okay, let's have a look now.
Is that a big number?
Yeah, some people got a big number, some people got a small number, so let's see what happens. What should I factor out? Yeah, the minus 9 now, not the 9. It's more convenient to take out minus 9. So that will be minus 9 x squared plus 10x plus 219 over 9. That will be minus 9 x plus 5 squared. And then it's 219 over 9 minus 25. So that's minus 2 over 3. So this becomes minus 9 x plus 5 squared plus 6 as the answer at the end. Which part? Here to here?
No, 2 up to 3.
Here to here?
Yeah, how do you divide 200? Yeah, this one.
Because the 9 is taken out.
Okay.
We divide each of them by 9.
Okay.
Yeah.
The next step?
The next step here
Yeah.
was 219 over 9 minus 25. Mhm.
Can you only take out positive now?
No, you can take a minus 9.
Oh.
Yeah. It's more convenient to do that. Yeah. Okay, next now. So let's have a look at why completing the square is useful. So let's look at I'll give a simple one actually. Can I scroll down?
Quadratic equation that can't be factorized.
Yeah, this is definitely one reason to use it. Another reason, let's take something like this. Y equals x squared plus 2x plus 10. Let's complete the square. Y equals x plus 1 squared plus what? 9. Now, this is useful because if you look at this really carefully, you can see this part here must always be positive. Why am I saying that?
Because it's squared.
Because it's squared, this has to always be positive. Squares are always positive. Okay, so you're okay with that so far?
Unless it's negative?
Unless there was a minus here, of course, which there's not. So right now, this part has to be positive. And this is just a 9. What is the smallest that this can be?
Minus 0.
The smallest it can be is 0. So this will be bigger than 0. It could equal 0. When will this equal 0?
Minus 1.
Yeah. It will equal 0 when x equals minus 1. So if you think about it, if this has to be at least 0 or bigger, and this is a 9, then what is the smallest y can ever be?
9.
It's 9. Because the only way it could be less than 9 is if this was negative. But it can't be negative. So in fact, this piece at the end is like the smallest the y value can be. It's the minimum y value. And this happens when this part is 0. So in other words, if you had something like y equals x plus 2 squared plus 3, you can know that the smallest the y can be is 3, and this happens when x equals minus 2. So this is one use of completing the square. It can allow you to find minimums. Yeah.
They ask you to draw graphs.
Yeah, and we'll do that later. Yeah. So some people have seen the graph before. If you know what the graph is, it has this shape to it. What you've just found is this point here on the graph. The minimum.
Minus
Yes.
2.3.
Where is it gone? Well, I should at least draw it in the right spot. So it'd be like here. Minus 1 and 9 was my answer. And there's another example underneath. That's a different example. Okay, so we'll do a couple of these. If you can write these two examples down. So this is where the minimum is.
minus 2 again.
Yeah, you want to make this part here a 0 because that's when you'll get the 3. So x has to be minus 2.
So that's to get the minimum value of y.
Yeah, to get the minimum value of y, you need to make this a 0 because this is the smallest it can be. Yeah, it's okay. Yeah. Shall we do another example? We'll do a maximum now. Yeah. Scroll down. Yeah. Let's take something like this one. Y equals minus x squared minus 2x plus 5. So first I should factor out minus 1. I'm left with x squared plus 2x minus 5. This will become minus 1 x plus 1 squared minus 6. So this becomes minus x plus 1 squared minus 6.
Plus 6.
Thank you, plus 6.
Uh-huh.
Now this one's a little bit different because I can write this one as y equals 6 minus x plus 1 squared. Again, this number here is always a positive, but we have a minus here. So it's like 6 minus a positive number.
Yes.
So if you think about it, 6 this time is the biggest y can be because you're reducing it, you're taking something away.
Yes.
What's the least you can take away? The least you can take away is 6 minus 0. When does that happen?
When x becomes x minus 1.
Minus 1. The y will be
6.
6. So this will be a maximum this time. On the graph, what you found is this point now. So it's still the same process if it's a maximum. There's nothing different. So yeah, how do you know if you have a maximum or a minimum?
Sign.
The sign. If this is a minus, what you have is a maximum, and if this is a positive, what you have is a minimum.
Or if we change the equation, like put a plus instead of a minus.
Where?
Like change the whole equation to become minus y plus x.
You put a minus here,
Yeah.
but then
Would that give us the minimum?
it would give you the minimum of minus y, which would be the maximum of y, because minus y flips the graph upside down. So it would give you a minimum, but minimum of minus y, which is the maximum of y when you flip it back.
Just one question.
Yeah.
Minus 6, and then you added 1 squared, which is 1.
Oh, how this part?
Yeah.
It was minus 5 minus 1.
Oh, okay.
Yeah. It's always a minus in that part, here to here. Okay, I want to give you one to try like this. I'll just write it at the bottom here. So I want you to find the maximum or minimum for this one. Y equals minus 5x squared plus 90x minus 412, and we're looking, of course, for the maximum. You got an answer?
Yeah.
Yep. Let's have a look. Y equals minus 5, x squared minus 18x, plus 412 over 5. Yeah.
Yep.
Minus 5,
X
x minus 9.
No, 9 squared.
Yeah, so 412 over 5 minus 81 is 7 over 5,
Mm-hmm.
which will be minus 5, x minus 9 squared minus 7.
Don't we half it?
I did. Not 18 became 9.
Oh, so we have it after the second no.
Yeah.
Oh, okay.
Yeah.
How did the?
Oh, did you have it at the beginning?
Yeah.
I don't know.
How did it become plus 412?
Ah, because I took out minus 5. So the signs get flipped on the inside here when a minus comes out. So, what is the x and what is the y at the maximum?
X is 9, y is negative 7.
Yeah.
Yeah. Okay, write this one down. Seems like it was a little bit of trouble. Minus 7. Minus 7 at the back. You use this number. It's a minus 7. And it was this number multiplied by this number. Oh yeah, minus 7 because it's that number. Are you asking me about this? Yeah, it's this number. It's minus 7. You use exactly what's here. If it's a plus, you use a plus. If it's a minus, you use a minus.
Can the answer different if it's minimum?
If it's minimum, you do it the same way. Yeah, the only difference is if it's minimum, this is probably a plus. But the steps are the same. Is that what you mean? Is that your question? Or did I misunderstand?
No,
No, Coco, don't be shy.
no, that's all I asked.
That's okay, yeah. So if it's minimum, it's the same steps, yeah. Okay, can I give you another one to try, but more difficult now? So this is a tricky one. Okay. Find B and C in y equals minus x squared plus bx plus c if the curve crosses the y-axis at y equals minus 42 and has a turning point at x equals 6. And if you're wondering what turning point is, this is just the name for a maximum or a minimum point. There's other names for it too as well. Does anyone know another name for maximum or minimum point? We can call it turning point. Yeah, now the problem with peak is that only means maximum. So we need a word that means maximum or minimum. Anyone know any?
I know it's called hyperbole when it's called
What do you call it?
inflection.
Not that one. It's not too different, yeah. Okay, so maximum or minimum
Stationary
points,
point.
Yeah.
we can call them stationary point.
Yeah.
And there's another one as well. That's another name for this one. Or also called a...
What's the first letter?
No, I'll tell you. Because I think they'll give it away. Vertex.
That, yeah.
Yeah, so these all mean the same thing. Turning point, stationary point, vertex, max, min point. They all mean the point here or the point here. So there's a lot of vocabulary for this.
Which more common?
In the exam, all four are used. Yeah, I've seen exams that use this word, this word, this word, and this word. So yeah, all four would be used. So you do need to know them all, I'm afraid. Okay, try this question. It's a bit hard, but I want to see if anyone can do it. So try this. Is the singular and vertices are the plural. It's the plural.
Oh, okay, I know.
For this one? Write it down, so we'll see. Finished? Know what to do? Oh, good. Finished?
Yeah,
Are you sure it's right?
I think so.
Okay. Finished?
What did you get?
Finished?
What is C? What's your answer for C?
There.
This one?
Yeah.
This?
Mm-hmm.
What is this?
7, 8.
What's your answer for C?
7, 8 minus.
Mm-hmm.
Negative 42.
Mm-hmm.
Oh,
I think
12.
you're
12.
Don't know. Let's see now.
isn't that crossing the x-axis means 0 point minus 42?
It's crossing the y-axis.
so x is 0.
Yeah.
So y equals
Minus
minus
42.
0
Minus
square plus
42.
0.
Oh, yeah, minus 42.
Okay, let's have a look at this now. So we have y equals minus x squared plus bx plus c. And you know it crosses the y-axis here. So you know that 0 minus 42 is a point. We can put this point in to get c, because we'll get minus 42 equals 0 plus 0 plus c, so c is minus 42. So we have y equals minus x squared plus bx minus 42. Okay, so we're half finished. Now, to get the b, we'll complete the square. Y equals minus bracket x plus b over 2 squared plus blah blah blah. I don't actually care about this part at the end. The reason is, where will the x be, or what will the x be at the turning point? Yep.
I think it was X.
Oh, sorry, thank you. Yeah, I just realised that right that second when you said it. Minus there, thank you. So what will the x be at the turning point? Looking at this formula. X should be equal to b over 2, but yes, it should also be equal to 6.
B is 12.
So b has to be 12. So the answer is y equals minus x squared plus 12x minus 42. Now this is a hard one, but I have seen this on the exam. It has been on the exam, okay? So please write this one down carefully if you didn't get it.
And that's a maximum.
And it will be a maximum as well. Yeah. You got this? Yeah. Did you do it the same way?
No,
Did you use derivative?
no.
You did it a different way. What did you use?
I just saw that the C is minus 42 and that the B has to be double the 6. So I did it for
Okay. You might not have been able to do that if I put a number in front of the x squared, because then that has to be factored out. So it didn't, but if you did that in the exam, would I give you full marks?
No, in the exam.
I think not. Yeah. Okay, can I go down now?
Just one more second.
It's okay, Starry? What? I care. I'm asking it's okay. Because I know how you feel about maths. So I'm just making sure it's okay. Yep. Okay. Now, if you have your calculator, what I want people to do for me is I want them to choose any number for x and put it in here, okay? So choose any number for x and tell me what you get. So I'll ask people what they get. Pick any number for x, but don't pick 0, okay, because I'm going to pick 0. So pick any other number, random number. You pick the number, okay? So just keep your answer on the screen. You're picking a number? Fine, yeah, whatever. Yeah. Okay, so have we all done a number?
What number? No.
Any number.
Yeah.
Okay, so what number did you pick? 6, and what did you get for the answer?
Oh, this is nothing.
Put 6 in and give me the answer, yeah. Okay, what number did you pick? And what did you get? 329. 89. So 329, 89. What did we get up here? 54. Okay, I'll pick 0, so I get 414. So what you notice is all the answers are positive. In fact, I know for this problem, you always get a positive answer. You can never get a negative answer. So even if you put in like -2, -3, this will still be positive. Yeah, you can check it out. No matter what number you put in, it'll be positive. And in the exam, they might ask you to prove that. They might say, prove that this is always positive. Yes?
You show them that it's a minimum and that the turning point is above the 0.
That's one way to do it, but you can even do it a little bit shorter than that without having to mention the graph. So to prove that this is always positive,
You put 0.
no, you complete the square. So you have 5 bracket x squared minus, what's that, 18x plus 414 over 5 greater than 0. 5 bracket x minus 9 squared, and then 414 over 5 minus 81 is 9 over 5 greater than 0. 5x minus 9 squared plus 9 greater than 0. But this is always bigger than 0 or equal to, and this is always bigger than 0 because it's 9, and 9 is bigger than 0. So when you add a number which is bigger than or equal to 0 plus a number that's bigger than or equal to 0, the result must be bigger than 0.
So you can just say, like, since there's a square, it must be positive. And
Yeah, it's because of the square is what makes this true.
And so when they ask in the question, prove why it's always 0, more than 0, you can just say like that.
Yes.
This is what I would need to see in the exam,
Oh,
because
okay.
what would happen, and let me just explain the marks in the exam. Like, for example, if this is probably going to be like 3 marks in the exam, so doing this completing the square, you know, is 1 mark, the process. Then you get 1 mark for getting the right complete the square answer here. So it's 1 mark for the method. 1 mark for the answer, and then 1 mark here for an explanation.
Mhm.
Now you don't have to write it exactly like this. You could write like a sentence explaining it. But if this was 3 marks in the exam, that's how the marks would go.
Okay.
So you do have to do something at the end for the last mark.
Then can I just like draw a graph instead of saying it?
I need to see something that looks like English. Okay, like a couple of words, something. Okay, something.
Oh, and like I usually just put 5 actually out like this. Would it be okay to?
What do you mean?
Like I don't
Take
usually.
the common factor from the
Yeah.
x only.
Yeah, I just take out the common factor from x.
Yeah.
No, I wouldn't like this in the exam. I need to see it more like this.
But it's
Oh, it's okay, but it kind of makes me a little sad when I look at it. I would feel much better if I saw it like this.
Okay.
Yeah. Yeah, it makes me a bit sad. So, this way, a bit more to write.
Okay.
Okay, did you write this down? Yeah, did you write this down? Okay, so I'll give you a few minutes to work on these questions. So, your homework, which you can start now for a few minutes, is A and B. Yep. A and B. So that means no homework for you this week. You're free from homework. Yeah. So you'll need to, maybe someone can send you the worksheet. Your account should be active by this Friday.
All of them?
Yeah, so you'll need one of your friends to send it to you. You'll do that, thank you. And you've got someone to send it to you?
A and B 1 to 6.
A and B 1 to 6. Can I close this? No, not yet.
What's the question for homework?
A and B 1 to 6.
So I can just write like this, and I will get 1 mark for explanation.
Yeah, it's 1 mark for the completing the square method, 1 mark for having the actual right answer from the process, and 1 mark for an explanation of why this is true.
So just write it like this, or
Something like this, yeah. I can close this now? Yep.